Now we will learn how to find angles between hour and minute arms of a clock. Here, in this example, calculate the larger and smaller angle between the hour and minute arms of a clock at different times. Here in these examples, all the times are given at perfect hours. That means at 0th hour or 4 AM or 6 PM or 8 PM or 11 PM. That is, no fractional minutes are given. That we will be doing later. So let us do one by one example. So here we are asked to find larger and smaller angle, two angles for every time. So 0 AM. So 0 AM, hour and minute will be here. Both the arms are here. So the smallest angle between them, the smaller angle between them is 0 degree actually. So the smaller angle is 0 degree, and the larger angle, this is the larger angle. So the complete revolution, which is 360 degree. Now the second one, 4 AM. So this is 1, 2, 3, 4. So hour arm is here, minute arm is here, this is 4. So this is the smaller angle and this is the larger angle. We know that in every hour, here this angle is 30 degree, because in 12 hours it covers 360 degree. So in every hour it covers 30 degree. So here 1, 2, 3, 4. So this 4 hour will cover 4 times 30 degree, that is 120 degree. So this small angle will be 120 degree. This one complete revolution is 360 degree. So this larger angle will be 360 minus this small angle. So minus 120, that means 240 degree. So at 4 AM, the angle between hour and minute arm, smaller angle is 120 degree and larger angle is 240 degree. At 6 PM, this is hour arm, this is minute arm. They make a straight angle. So straight angle is 180 degree. So here both smaller angle and larger angle, whatever we consider, will be 180 and 180. For next question is for 8 PM. So 6, 7, 8. So this is hour arm, this is minute arm. So this is the smaller angle and this is the larger angle now. So in smaller angle, 1, 2, 3, 4 hours are there. Within the smaller angle, 1, 2, 3, 4. So each hour covers 30 degree. So 1, 2, 3, 4. 4 hours will cover 4 times 30. That is 120 degree. So the smaller angle will be 120 degree and the larger angle will be 360 minus 120 minus 120, that is 240. So this larger angle will be 240 degree. Another one is given 11 PM. So 11 PM, this is 11 PM. This is minute arm and this is hour arm. So this is the smaller angle and this is the larger angle. So within smaller angle there is only 1 hour, and 1 hour means 30 degree. So the smaller angle will be 30 degree and the larger angle will be 360 degree minus this 30 degree, that means 330 degree. So it's easy. So when these times are given in perfect hour, there is no minute part, then it is very easy to calculate the angle, either smaller or larger angle between the hour and minute arms. Now we will find the angle between hour and minute arms of the clock when both hour and minute part will be there. So we will be calculating the larger and smaller angles between two arms of a clock, assuming that the hour arm moves proportionally with the minute arm. That means, so for example here 15 AM. So the minute arm is here 15 minutes and the hour arm, it's not straight at 12 because already 15 minutes time is gone. So the hour arm started moving towards 1, but how much it will move will determined by the minute. That is, in 60 minute time it has to move from here to here. So in 15 minutes time it will be moved to some extent. So this angle this hour arm is no longer at 12 and it is did not reached yet at 1, so it is somewhere in between. So this time, because of this minute part, we will be calculating this angle as well, and then we will be finding this angle between the hour and minute arm, the smaller angle and the larger angle. Let's do one by one examples. This will make our concept clear. So first, if we consider this is our reference point, then the minute arm, in 15 minutes time, the minute arm moves. We know in every minute the minute arm moves 6 degree. So in 15 minutes the minute arm moves, in 15 minutes time it moves 15 times 6, that is 90 degree, and in 60 minute time the hour arm can move from here to here, that is, this part is 1 hour span is 30 degree. We already know, because the 12 hours is 360 degree, 1 hour is 30 degree. So in 60 minute, in total 60 minute time, hour arm moves from here to here, that is 30 degree. So any fraction of minutes, the hour arm will move in between. So the hour arm moves in this 15 minute time. When the minute arm moves from here to here, that is 15 minutes, the hour arm will move 15 division 60 times 30 degree. Why? In 60 minute time, if in 60 minutes the hour arm moves 30 degree, so we are told that it will move proportionally. So in 15 minutes time it will move 15 division 60 times 30 degree. So if we calculate it, we will get it 30 and 60, it will give 2, so 7.5 degree. So here the hour arm moves 7. From here we are calculating from here. So from here the minute arm is moving 90 degree, and from here the hour arm is moving 7.5 degree. So this angle, hour arm to minute arm, this angle will be now the angle between hour arm and minute arm will be, minute arm is moving 90 degree and hour arm is moving just 7.5 degree. So that difference, that is 90 degree minus 7.5 degree, will be the smaller angle between the hour arm and minute arm. So we will get 82.5 degree. So this is the smaller angle between hour arm and minute arm when the time is 0:15 AM. What will be the larger angle? This larger angle, simple, as soon as we know the smaller angle, the larger angle will be, so this is the smaller angle, the larger angle will be 360 degree minus this smaller angle 82.5 degree. So which will be, if we calculate it, we will get 277.5 degree. So let us do this second example. Here the time is 3:40 AM. So 3:40. So if we calculate from here, the reference from here, the minute arm is moving 40 minutes. So minute arm will move 40 minutes and each minute 6 degree. So it will be 40 times 6, that is 240 degree. And the hour arms will move 3 hours and 40 minutes. So 1 hour, 2 hours, 3 hours. So this 3 hours is complete 3 hours, and each hour, this one segment is 30 degree. So that means 3 hours will be 3 times 30 degree plus another for 40 minutes. The hour arm is not at 3, it is moving towards 4. For 40 minutes it will moving, for 1 hour 60 minutes it moves 30 degree. So for 40 minutes it will move 40 division 60 times 30 degree, because in 60 minutes, for one complete revolution of this minute arm, 60 minutes, the hour arm moves from here to here, that is 30 degree, but here it's 40 minutes. So in 40 minutes time, for 40 minutes hour arm will move somewhere here, which is 40 division 60. For 60 minute total one movement is 30 degree. For 40 minute it will be 40 division 60, 30. So this will be, if we calculate it, we will get 110 degree. So the minute arm from this reference point, we are calculating everything from here. The minute arm in 40 minutes move here, which is 240 degree, and the hour arms move 110 degree. So this angle in between these two will be 240 minus 110. So the smaller angle between the hour arm and minute arm will be 240 minute arms position, and hour arms position is minus 110. So it will be 130 degree. So this small angle is 130 degree. So now this large angle, we can find it. Larger angle will be 360 minus 130. So it will be 230 degree. So this larger angle is 230 degree. Let us do two more examples. At 5:55. So 5:55. So this is minute arm at 55, and this is 5, and since it is 55, our arms is very close to 6 but not 6. So if we start from here, the reference angle is here, and if we rotate all the way through, so for 55 degree, 55 minute, so minute arms position, minute arm will rotate 55 times 6, that means 330 degree, and the hour arm will rotate full 5, up to this is full 5, that means 5 times 30 degree, because if each of the span is 30 degree, plus for this 55 minutes it will rotate 55 division 60 times 30, because 60 minutes rotates 30 degree, for 55 minutes it will rotate this much. So if we calculate this, we will get 177.5 degree. So this total angle for minute is 330, and for hour this total angle is 177.5. So this small angle will be minute angle minus hour angle. So it will be smaller angle will be 330 degree minus 177.5 degree, which will be 152.5 degree. So this smaller angle is 152.5 degree. So this larger angle will be 360 degree minus this smaller angle 152.5 degree, which will be 207.5 degree. So this calculation will give us 207.5 degree. So this larger angle is 207.5 degree. Let us do this fourth example. Here the time is 10:12 p.m. So this is hour arm 10, and this is 12, minute arm is 12. So 5, 10, 12. So if we consider this as the reference point, then this is the minute arm. So minute arm is going 12 minutes. So for 12 minutes, its angle will be, for minute arm, 12 times 6, that is 72 degree. So from here minute arm is moving 72 degree, and the hour arms is moving all the way up to, the hour arm is moving all the way up to 10, because 10 p.m. 10, plus for 12 minutes it is moving a little bit more. So the hour arm is moving 10 hours, for 10 hours it is moving 10 times 30 degree, because every hour it moves 30 degree, plus for 12 minutes it will move 12 division 60 times 30 degree. So we will get, this calculation will give us, actually it's not 12, 10, because complete 10, because 10 hours and 12 minutes, so complete 10 hours, and for every hour 30 degree, plus for this last 12 minute it will be 12 division 60 times 30. So if we calculate it, we will get 306 degree. So this whole angle up to this point is 306 degree, and this is 72 degree. So basically here, if we take this two difference, we will be getting this large angle. So here we will be first getting the larger angle. So the larger angle is, so this total angle minus this minute angle. So now here we will subtract the minute angle from our angle. So it will be 306 degree minus 72 degree, which is 234 degree. 234 degree. And then the smaller angle will be, because if this is the larger angle, the smaller angle will be 360 minus this larger angle. So it will be 360 degree minus this larger angle 234 degree. So we will get 126 degree. So this is smaller angle, this smaller angle is 126 degree. So here we saw 4 different cases how we can calculate the angle between hour and minute terms when both hour and minute values are present, and how to calculate larger and smaller angles, that is both larger and smaller angles.